Good morning, students. So as we are discussing conversions chapter and we are in calendar. So the next question in calendar is this. 7 by 6 of a leap year is equal to how many weeks? Try this question, all of you. Yes, Mayuk, you can answer this. Yes, Mayuk. Yes, Mayuk. Okay, how can we solve this? Leap year contains how many days?
Sir, 366.
So 7 by 6 of leap year contains 366
Yes,
days.
12 months.
Yes, and we want to convert this into weeks, right?
Yes, sir.
How to convert days into weeks?
So divided by 7.
Can I write 1 by 7 also?
Yes, sir.
Okay, what will be the answer? 7 cancels. And next,
61. So 6 divided by 3.
36 and 1. This is 61. Which option?
So C.
C. Okay, all of you can copy this. Students, you can copy later. Only you can have a book with you. You can again revise the class and copy later. Next, we are going to discuss temperature conversions. So we are going to use two different units for temperature, that is degree Celsius and degree Fahrenheit. So what is the conversion between them? So you can say F is equal to 9 by 5C plus 32. Or we can simply remember by this C by 5 is equal to F minus 32 by 9. If you remember this, we can convert from any system to any system. So you can just remember this. C by 5 is equal to F minus 32 by 9. We can convert from centigrade to Fahrenheit and Fahrenheit to centigrade. So this C is called centigrade as well as Celsius. You must remember this formula. So using this, we can convert from centigrade to Fahrenheit as well as Fahrenheit to centigrade. So all of you, try the first question. You can have rough books with you and try this question, all of you. The normal body temperature of a human being is 37 degrees Celsius. Convert it to degree Fahrenheit. We have to convert from centigrade to Fahrenheit. Use the same formula. C by 5 is equal to F minus 32 by 9. Who will give the answer for this? Javant, can you answer? Javant?
Sir,
Yes.
sir, your voice is repeating 2 times, sir.
Okay,
Sir, your voice.
Javant, you try to leave the class and join again. Ashwardhan, can you answer?
Sir,
Yes. Just now I told you one formula. What is that?
Sir, what?
Just now I told you one formula for the conversion.
C by 5 is equals to 5 minus 32 by 9.
C by 5 is equal to F minus 32 by 9.
9.
But the given temperature is in centigrade or Fahrenheit.
Centigrade.
So in place of C, we should use 37, right?
Yes, sir.
So 37 by 5 is equal to F minus 32 by 9. I want the value of F. You know transposition method, right?
Yes, sir.
If you transpose 9 from right to left, what will you get?
Sir, into.
So that is 37 by 5 times 9. And if you transpose minus 32 to the left side, what will you get?
Sir, plus 32.
Plus 32, that is equal to F. So we have to simplify to get the answer, right?
Yes, sir.
Okay, 37 divided by 5. How can we simplify this?
Sir, we can't simplify.
We can do cuttings now till we get decimal, right?
Yes, sir. Sir, but a decimal, how like we can.
See, I'll tell you two methods to get 37 by 5. Either we can do cuttings here like 37 by 5. 5 sevens are 35. What is the remainder?
Sir, 2.
If you use decimal, 2 will become 0, right?
Yes,
20. So 5
sir.
fours are 20. This is one way, right?
Yes, sir.
Or the other way, what I suggest is denominator is 5. Is 5 a factor of 10?
Yes.
That means it can be converted into 10, right?
Yes.
So whenever denominator is becoming a 10, then easily we can write decimal. So denominator I am multiplying by 2. Denominator I am multiplying by 2. So numerator also I will multiply by 2. Is there any change in the fraction now?
Sir, no.
No. Why I am doing this? Because 5 2 becomes 10 in the denominator. It is easy to find the decimal, right?
Yes,
Now
sir.
simply you should find the product of this 2, 37 and 9 products.
Sir, 74. That's 237?
2 into 37 into 9.
1 minute, sir. I'm doing that only. Sir, 666. 666. 666.
So you got 666, right?
Yes, sir.
And what is the denominator? 5 twos are 10.
10.
Plus 32 is equal to F. Now you see 666 by 10, easily we can write decimal. What is that?
Sir, 6.6.
No, 10 is containing 1 0. How many decimal places we want?
2. 66.6.
One decimal place you should say. Starting from right, we will count, not from left. Can you tell me, Harshav, then in 66.6, how many decimals are there?
Sir, 1.
One. Count from right, not from left. Plus 32 is equal to F. So finally, we got the value of F. What is that?
Sir, it will come in this way. Sir, 1 minute. Sir, 98.6. Sir,
Yes,
sir, 98.6.
98 points. Therefore, so which is the approximate value for this?
Sir, in a Fahrenheit, so there is approximate value or what near
Nearest decimal, we can find the answer. What is the nearest answer for this in the given options?
sir, 98.5. Sir, there is no
Approximation 98.5 degree Fahrenheit. So this is not exactly equal, approximately equal to we got.
sir exactly any Celsius have Fahrenheit like
No, in
any.
the given options, option D is the closest answer, right?
Yes, sir. Sir,
Approximate.
let's also use this formula. Sir, I have a doubt. In Fahrenheit to converting Celsius also we want to use this only. C by 5 is equals
Yeah,
to.
same formula. I'll take one more question for that.
Sir,
So this is how we are going to convert between the centigrade and Fahrenheit using this formula. Same formula can be used to convert from Fahrenheit to centigrade also. We'll take more examples. Next question. The value of 200 degree Fahrenheit in degree Celsius. Now it is the reverse. That means Fahrenheit to Celsius. Who will give the answer for this? Sasha, can you give the answer for this?
Before we not copied.
Copying, you can do it later, as I told you yesterday. You can watch the recorded lecture later for revision and you can copy the notes. Mayuk? Yes, Mayuk? Mayuk, how to convert this Fahrenheit to Celsius? Which formula I can use? Just now I told you, no? C by?
C
Yes.
minus 32.
C by 5 is equal to F minus 32 by 9. You remember this? You can convert from any system to any system, right?
Okay, sir.
The given question is in Fahrenheit or Celsius.
The Fahrenheit.
That means it should be substituted in the place of F or C.
Yeah.
So C by 5 is equal to, in place of F, we use 200. So 200 minus 32 divided by 9. I want the value of C. So transpose 5 to the other side.
So
What is 200 minus 32, Mayuk? What is 200 minus 32?
148.
Why 148? 168 divided by 9. And if you transpose 5 to the right side, it will become multiplication, right?
Yes, sir.
So 168 into 5 you can solve first.
It's 40. It's 41.
168 into 5, you're getting 840 divided by 9. 9 nines are 81. What is the remainder?
So 30.
30. So 9 threes are 27. 3 is remaining, you can use decimal. 3 becomes 30. Again, 9 threes are 27. So we got the closest answer, right? Still remainder is there, but we got the closest answer is 93.3 degrees Celsius. Which option?
So B.
Option B. All the students remember, copying you can do it later. Now only you should have rough books with you and try all these questions. Later you can watch the recorded lecture and copy the notes. So this is how we are going to convert from centigrade to Fahrenheit and Fahrenheit to centigrade using this. So all of you remember this. What is this formula? We have to remember C by 5 is equal to F minus 32 by 9. Using this we can convert from one system to other. One more question next. Who will give the answer for this can raise a hand. Convert 131 degree Fahrenheit into Celsius scale. Similar type of question as previous one. Sahasra, will you answer this question? Sahasra,
Sir,
will you answer this question?
sir, I'm trying, sir.
What is the conversion formula I told you just now? What is the conversion formula I told you just now? You don't remember, Sahasra?
Sir, I'll take. Sir, I will take.
Yeah, tell me.
So C by 5 is equals to
C by 5 is equal to,
F minus 32 by 9.
yes, use this formula. Now the given question is in terms of foreign heat. So the value 131 should be substituted in place of C or F.
Sir,
131 should be substituted in the place of C or F.
F.
We can write C by 5 is equal to 131 minus 32 divided by 9. What is 131 minus 32? What is 131 minus 32?
So 99.
99 divided by 9. If you transpose 5 to the right side, it will become multiplication. Now, can you do cuttings here?
Yes, sir.
9 ones, 9 elevens. What is 11 fives, sir?
55.
55. Therefore, we can write the answer. 131 degree Fahrenheit is same as 55 degree Celsius. Very good, Sastra. So this is about conversions topic, and next we are going to discuss the next chapter, square square root and cube cube root. The next topic is square square root and cube cube root. So what is a perfect square or what is a square? You take any number like x. If you multiply x two times, you get a number, and that is called the square of x. And we write x square. That means the square of x is called x square. Similarly, the opposite operation is the square root of x square, we will call it x. So both are true. X into x is equal to x square, and square root of x square will be x. Let's take one example. For example, I want to find 1 square. 1 square means what? 1 multiplied 2 times. 1 ones are 1. I want to find 2 square. 2 twos are 4. So 2 square is 4. 3 square I want to find, that is 3 threes are 9. 4 square, 4 fours are 16. 5 square, 5 fives are 25. See, we got 1 square is equal to 1. From that, if you transpose square to the right side, it will become square root. So square root of 1 will become 1. Similarly, we got 2 square is equal to 4. You transpose square to the other side, you get square root. Square root of 4 will become 2. Similarly, square root of 9 will be 3. Similarly, square root of 16 will be 4. And square root of 25 will be 5. So I will give you a work, that is complete this up to at least 32 square. Complete this up to at least 32 square, you must remember. And the square roots also you can write, because most of the times we are going to use squares and cubes, even in series completion or in these problems, square roots and cube roots. Regularly we are going to use the values up to 32 square. So we need not do the multiplication every time and waste the time. You just try to remember up to 32 square. And then cubes. Whenever any number like x multiplied 3 times, then we call the product as cube of it. That is x to the power 3, or simply we call x cube. When you transpose cube to the other side, we can write cube root of x. Cube root of x cube will be x. Now we'll take 1 cube. 1 cube means 1 multiplied 3 times. 1 into 1 into 1 will be 1. So transpose cube to the other side, you get cube root of 1 will be 1. I want to find 2 cube. 2 multiplied 3 times. 2 into 2 into 2. 2 twos are 4, 4 twos are 8. So transpose cube to the other side. You get cube root of 8 is equal to 2. Then 3 cube. 3 multiplied 3 times. 3 times 3 times 3. That is 27. So you can transpose cube to the other side, will become cube root. Cube root of 27 is 3. 4 cube. 4 multiplied 3 times. 4 times 4 times 4. 4 fours are 16. 16 fours are 64. Transpose cube to the other side, give cube root. Cube root of 64 will be 4. 5 cube. 5 times 5 times 5. 5 times 5 is 25. 25 into 5 is 125. Transpose cube to the other side, will get cube root. Cube root of 125 is 5. So complete this list. Complete this list up to at least 12 cube, and remember, because they are also regularly used ones, so you must remember squares up to 32 and cubes up to 12. You complete this list and then try to remember, because most of the time we are going to use. And there are some ways to find square roots and cube roots. Let me take an example for each. So first I'm going to discuss methods of finding square roots. Before that, perfect square, we got a question here. All of you try this question. This question came in 2016 descriptive exam for 3 marks. Find the square numbers lying between 75 and 225. Who will give the answer? Surya, can you give the answer? Surya?
Sir,
Yes, Surya?
sir, can I say answer?
Yeah, you can.
Sir, sir, find the square numbers lying between 75 and 225.
Yes.
Sir, first one, hmm, 81, 9 square, sir.
Yeah, 8 square 64 is not going to lie between them. After 8, you can go for 9 square. So
9 square.
9 is 81. Then
100, 10 square, 100.
square 100.
11 square, 121.
Yes.
12 square, 144.
Yes.
13 square, 169.
Yes.
14 square, 196.
Yes.
Sir, and 15 square, 225.
You should not write 225. Why? Because they said between.
Sir, between,
Between means the endpoints are included or excluded.
sir, excluded.
That means we should not write the endpoint 75 and 225. So between 75 and 25, we have the perfect squares, these numbers 81, 100, 121, 144, 169, and 196. Okay, you can copy
Yes,
this later. Just listen to the class and use refer wherever you require answers. And next, the methods of finding square roots we are going to discuss. So before we solve these questions, Surya, you can mute yourself now. So we discuss methods of finding square roots. So there are two methods we are going to use. Method number one. Method number one is called prime factorization method, or simply factorization method. Prime factorization method. Suppose we have a number that is, let's take an example. Example, find the square root of, we'll take a number, 1,29,600. Or simply they may ask what is the value of square root of 1,29,600. Let's solve it using prime factorization method. So what we need to do is, as we discussed in the number system, we can do prime factorization using continued division method 129,600. You can take only prime numbers to divide. So is it divisible by 2? Yes. 2 6 are 12, 2 4 are 8, 1 is remaining 16, 2 8 are 16, 0 0. Divide by 2 again, 2 3 are 6, 2 2 are 4, 2 4 are 8, 0 0. Again divided by 2, 2 into 16 32, 2 2 are 4, 0 0. Again divide by 2, 2 8s are 16, 1s are 2, 0 0. Now it can be again divided by 2. 2 into 40, 80, 1 is remaining, 2 5s are 10, 0. 2 into 20, 40, 2 into 25, 50. Now it is not divisible by 2. Check whether it is divisible by 3 or not. Yes, sum of the digits is divisible by 3. 3 6 are 18, 2 is remaining 22, 3 7s are 21, 3 5s are 15. Again it is divisible by 3. 3 2s are 6, 3 2s are 6, 3 5s are 15. Again it is divisible by 3. 3 7s are 21, 3 5s are 15. 3 into 25, 75. 25 is divisible by 5. 5 5s are 25. So whenever you get a prime number, you can stop. Now 129,600. This have the prime factorization. 2 repeated how many times? 1 2 3 4 5 6 times. So 1 2 3 4 5 6. Now 3 repeated how many times? 1 2 3 4 times. 1 2 3 4. 5 repeated how many times? 2 times. So therefore, to find the square root of 129,600, this method, prime factorization method, from every pair of two factors, we are going to take only one factor. 2 2 is a pair. We can take 2. 2 2 is a pair. From that pair, we can take 2. 2 2 is a pair. We can take one number 2. From this pair 3 3, we can take one 3. From this pair 3 3, we can take one 3. From this pair 5 5, we can take one 5. So 2 5, we do it later because 2 5s are 10. Simply we can add 0 at the end. 2 2s are 4. 4 3s are 12. 12 3s are 36. Now add 0 at the end, that is 360. Therefore, we got the square root of this number is 360. What is this method called? Prime factorization method. Now, for the same number, we are going to apply one more method that is called long division method. I hope everybody understood this method. Now I'm going to discuss the next one, that is long division method. So later, while you are listening to the class in recorded lecture, you can pause it here and you can copy. Next, we are going to discuss method number 2, that is long division method. Method number 2 is called long division method. So let's take the same number again. Same question. Find the square root of 129,600. I want to find the square root of this number using long division method. So first write that number 129,600. So starting from right to left, pair two numbers. So these two digits are paired, these two digits are paired, and these two digits are paired. So what if there are odd number of digits? That is a question. For example, in this question, we have something like 4 extra. We don't know we have this exact square root or not, but let us see. if there are odd number of digits, these two will be paired, these two will be paired, these two will be paired, but this is remaining. Then what we can do, we can use 0 here and we can pair like this 0 4. So because this question is not having 0, so now pairing the digits, 2 digits, 2 digits, 2 digits. Okay. Next, what we are going to do is, now we are going to start the long division method. So you use a line here, and what are we going to do? You are going to use the quotient place here. So first consider this 12. So now, as we remember the squares up to 32, you keep on reading squares. Which square is just below 12 and it is the largest? That is 1 square 1, 2 square 4, 3 square 9, 4 square 16. 16 is not less than 12. So just below 12, the greatest value is 3 square 9. So what you do is 3 threes are 9. Now you subtract. 12 minus 9 is 3. Immediately you take down the next group down. The next group is 9 6. You take it down 9 6 here. Whatever number is left here, you make it double. 3 twos are 6. Just write 6. And remember one thing, this blank and this blank should be filled by the same digit so that the product is less than 396 and it is the largest one. Suppose if I use 1, 61 into 1, 61, less than 396. Let's take 2. We want the largest possible value which is less than 396. 62 into 2, 124, still less. 63 into 3, that is 189, still less. Let's use 4. Here 4, here also 4. Same digit we have to use in the both the places. 64 into 4, 256, still less. Let's use 5. 65 into 5, that is 325, still less. If you use 66 into 6, that will be 396 exactly we are getting. So exactly equal also we may get or less than. So we can take 6 also. 66 into 6 will be 396 exactly. So we got 0. Take down the next group down, that is 0 0. So whatever number you got, you have to double it again. 36 twice is 72. Okay. This blank and this blank should be filled by the same digit. So you can use 0. 720 into 0 is going to become 0. And we get the answer, remainder 0. So the quotient is 360. That means this is the square root of the given number. I'm going to take more examples in this method for further questions. So this is the method. Square root of 129600 is equal to 360. That is 360. We got the same answer for both the methods. So to find the square root, we have these two methods. Prime factorization method and long division method. And even prime factorization method can be used for finding cube root also. Let's take an example for that. How to find the cube root of a number using prime factorization method. Next, let us find cube root of a number using prime factorization. Method of finding cube root. So we take a question, find. Okay, let me consider a question here. Find cube root of this number. Okay, what we are taking is, let's find the square root, cube root using prime factorization method. 216000, let us prime factorize this. It's divisible by 2. 2 ones are 2, 8s are 16. Whenever you are taking two digits, don't forget to use this 0. Don't write directly 8. So 0 0 0. 2 5s are 10. 2 4s are 8, 0 0 0. Next, 2 into 27, 54, 0 0 0. Now let's divide by 3. Yes, 2 also it's divisible. Let's take 3. 3 nines are 27, 0 0 0. 3 threes are 9, 0 0 0. 3 ones are 3, 0 0 0. Now it's divisible by 2. 500, 2 into 250, 2 into 125. Now it's divisible by 5. 5 into 25, 5 into 5. So let's write it as 216000. The prime factorization is 2 repeated how many times? 3 times. And again 3 repeated 3 times. 2 repeated 3 times. 5 repeated 3 times. So same as finding square roots. There we found two same digits grouped together as pair. But here to find the cube root of 216,000, 2,16,000, what we do is we group three similar digits together: 222, 333, 222, 555. From the first group, we take this 2. From the second group, we take this 3. Third group, we take this 2. Fourth group, we take this 5. That means from every group, you take one number and simply you multiply them. 2, 5, we multiply at the end because 2 5s are 10, we can add 0 at the end. 2 3s are 6, just add 0. So the answer is 60. Therefore, we got cube root of 216000, that is equal to 60. So this is how we are going to find cube root using prime factorization method. So while you're watching the recorded lecture later, you can pause it here and you can copy this. And next, we are going into the previous year questions. So all the students, now we can try these questions. Okay, this question came in 2020 exam. So all of you simplify this, and if you are interested in answering, can raise a hand. Who will give the answer for this? Yes, Ritvik, you can answer. Ritvik,
Sir,
yes.
yes, sir,
Yes, Ritvik, tell me.
sir, 625 square root is 25, sir.
Okay, as you remember squares up to 32, so we know square root of 625, that is 25. 25 divided by 11 into 14 divided by, what is square root of 25?
Sir, 5, sir.
5 into 11 divided by 196 square root,
Sir, 14.
14. Now we can start cancellation. So can you help me
Okay.
in doing cancellation?
Yes, sir. Sir,
Yes, Ritvik.
14, 14 cancel.
14, 14. Next.
Sir, 11, 11 cancel.
Next.
Sir, 5 ones, 5 fives.
5 ones and 5 fives. So what is the final answer?
Sir, option A, 5.
Option A. Very good, Ritvik. All of you can copy this later, but this is the answer. You can copy this later. Next question. All of you try this. This question came in 2020 exam. The product of two numbers is given 1296. If one number is 16 times the other number, find the smaller number. We'll give the answer for this. The product of two numbers is given 1296. If one number is 16 times the other, then find the smaller number. Arush, can you give the answer for this? Arush? Arush, am I audible? Arush, you're not audible to me. Try to leave the class and join again. Abhiday, can you answer this question? Abhiday?
Sir,
Yes, Abhiday. Read the question again.
the product of two numbers is 1296. If one number is 16 times the other, find the smaller number.
Okay. How to solve this?
Sir, you should first write x into 16x into x.
Okay, let us call the smaller number as x. Then the greater number will become
16x.
why? Because they said one number is 16 times the other number. What is 16 times x? 16x. Right? Yes, Abhiday. So they said the product of these two is equal to 1296. From this, we need to find the value of x, right? How to solve this, Abhiday?
Equals 16 to
You're not audible clearly. Speak loudly.
equals equals 16 to the other side.
16x square is equal to 1296. Abhiday, your voice is trucking. Mayuk, can you continue from here? Mayuk, can you continue from here? Speak loudly, Mayuk.
Okay, sir.
Can you continue from here? What we can do here?
So first x is
First, you transpose 16, right?
yes, sir.
So, if you transpose 16, which operation are you going to get?
So division.
1296 divided by 16. Okay. Can you help me in doing division?
Yes, sir.
So, how can we do this?
And 16
Yes, 16.
sevens are
16 sevens are how much?
81, 81, 81.
Yes, Mayuk,
one to
you can check 16 8 once, 16 eights.
yes, sir. So 120.
Yeah, 16 8 we have to use, right? 16 eights are 128. So 129 minus 128, what are you getting?
So 116.
Yes, 1 followed by 6 is 16. Then 16 table, 16,
1 sir.
16 ones. So we got x square is equal to 81. As we know the square roots, squares and square roots up to 32. So x square is equal to 81. If you transpose square on the right side, what will it become?
So 9.
First it will
So
become square root, right? X is equal to root 81. What is root 81?
9.
9.
So
So
9 into 9 is less.
the answer is 9 or 16 times 9?
So 9.
9 because they asked a smaller number. Therefore, the smaller number. Suppose in place of smaller number, if they ask greater number, what you would be doing?
Just 9 into 16.
Yes. Here in the first sentence of the question, x is the smaller number and 16x is the greater number. Because they asked a smaller number, our answer is 9. If they asked greater number, then our answer will be 16 times 9. So the answer is 9 here, option D. Very good, Mayuk. You can mute yourself. So D is the correct answer. So later while revising, you can copy this again. So the answer is 9. All of you take out your rough books and try all the questions. So we got the answer 9. Next question. Yes, this one. This question came in 2020 exam. So square root of 1089 divided by 121. So I forgot to tell you two properties. I will tell you now. Then we will continue this question. The property is, so it is about the square root of product and square root of quotient. See, first let's take square root of product. Square root of product of two numbers a and b. We can write it like separated square root we can give. That is, we can distribute the square root to both the numbers. Root a times root b. We can always do this. And square root of a divided by b. Okay. We can also distribute the square root for numerator as well as denominator. Root a divided by root b. But some students are distributing for addition and subtraction. Root a plus b. Can I write root a plus root b? We cannot write. This is wrong. Root a minus b. Can we write it as root a minus root b? This is also wrong. So these two are wrong. So we cannot distribute the square root over addition and subtraction, but you can distribute over multiplication and division. So these two properties you must remember. So based on this, we got a question here. So all of you can try this now. Square root of 1089 divided by 121.
Sir, can I?
Mike, let's give choice to other students. Aryan, can you answer this?
Sir,
Yes, Aryan.
sir, I did not understand what you said.
The square root, if it is there for a product, then square root can be separated for both the terms of the product. You can separately write root a into root b. Similarly, as quotient also, root a by b is equal to root a divided by
Yes,
root.
sir.
Okay.
Sir, okay, sir.
So can you solve this question now? See, division, can you write in fractional form, Aryan? Aryan, are you there? Himateja, can you continue from here?
Sir,
Can you write the division form as fractional form?
yes, sir.
Okay, how can you write?
1,809
It's not
by
809. It is not
by
809. It is 89 divided by
by
131. How can we distribute to both numerator and denominator?
sir 33 by 11.
First, what you do is you distribute the square root. Square root of 1089 divided by square root of 121, right?
Yeah.
So
Yes,
we
sir.
don't know the square root of 1089. Can we do it by long division method? Himateja,
Yes,
you
sir.
understood long division method?
Yes, sir.
Okay, two digits we have to group from right to left or left to right.
Uh, right to left.
So 89 and 10 will be grouped. So this 10. So which square is less than 10 and it is the greatest? 1 square 1, 2 square 4, which one?
Yes, sir.
6 is 6 a perfect square.
3, sir.
Yes, 3 threes are 9. Now you can subtract. 9 minus 10 minus 9 is 1. Take down
And
the next group 89. Now what is said in the long division method? Whatever number you got, double it. 3 twice. What is the answer?
9.
3 twice, 2 times.
3 threes are 9, sir.
3 2 times I am asking, not multiplication. 3 into 2.
6.
So this blank and this blank should be filled by the same digit. So which digit will give the answer 189?
3.
63 into 3, you are going to get 189, right? Then subtract, you'll get the remainder 0. So what is the square root of 1089?
33.
Yes, so here you can write 33 now. Root 121 we remembered already. What is root 121?
11.
Now you can do the cuttings to get the answer. Yes, what is the division?
11 threes are.
11 threes are 33, so the answer is 3. Okay, you get the answer option A. Very good, Himateja. You can mute yourself now. You can copy this later. while watching the video again for revision. You can pause it here and you can copy. Next question, all of you.
Yes, sir. Yes, sir.
Okay, this question came in 2019 exam. If the square of a number is added to the square of 28, then the result is 1808. What is the number we should find? This is the last question in maths. After that, we are going to start English. Um, Pranay, can you explain this question? Pranay? Pranay, can you explain this?
Sir,
Read the question.
sir, I want to explain previous question, but I want to,
Yeah, you are able to solve this one also. First, read the question.
if the square root of a
Not
number is
square root. Read the question properly. Where is square root? They said only square.
if a square of a number is added to the square of 28, then the result is 1808. What is the number?
Okay. They said if the square of a number. This number, which number is that you know?
No, sir.
Can we use a variable like x?
Yes, sir.
So what is square of x?
X square.
Yes, x square. They said x square is added to what?
28 square.
So we can write x square plus 28 square. They got the result how much?
1808.
From this equation, can't you find the value of x, Pranay?
Yes, sir.
What is 28 square?
One second.
28 square, you know, no, you remember. We remember squares up to 32, right?
Yes, sir.
What is 28 square? Pranay, still you didn't remember 32 squares. See, regularly we are going to use them, and if you depend on multiplication, you will unnecessarily waste time. Up to 32, you must remember.
Okay, sir.
Okay, what is 28 square?
784.
So transpose 784 to the right side. Addition becomes?
Subtraction.
So 1808 minus 784. What is the answer? Here only we can do two digits. 84 and 8 subtraction. Take borrow.
1024.
Let me check.
Uh,
Yes, getting 1024. Now you want the value of x. Transpose square to the other side. What will you get?
Sainik. Sir,
Pose square to the other side. What will you get?
square root.
Yes, we get x is equal to square root of 1024. So square root
Sir,
of 1024, what is that?
sir 32.
Yes, we remember squares up to 32, no? Directly we can write 32. So the answer for this question is C. Very good, Pranay. You can mute yourself. You can check the solution as well. 32 is the answer. So later while you're watching the video to write notes, you can pause it here and copy this. Okay, I stopped maths class here and we're going to start English. So English, last class, I think we were discussing verb and modal. Yeah, I gave you all the exercise questions and they're done. We're going to start the new topic today, that is after verb. Today we're going to start adjective. Just give me a second. Yes, students, next topic is adjective. So what is adjective? First, let's go through the definition. A word which is used with a noun or pronoun to describe it, that is type, which type it is, to describe its place, where is it, a number, how many are there, singular, plural, or how many number, or amount also, quality is also is known as adjective. Adjective, there is another name used, that is describing words. So they describe about nouns and pronouns. Suppose here Ramesh is an intelligent boy. Here Ramesh is a noun, name of a person. Intelligent, this word is describing about Ramesh. That's why it is a describing word, or we also called adjective. Boy is also noun. And my mother is very famous cook. So here, mother is noun, famous cook. So here, cook is noun and famous is saying about the quality of the mother. That means about mother. So famous is the adjective here. So what is adjective? They are words which are describing about nouns and pronouns like type, place, number, quality, color. All colors are adjectives like this. And next types of adjectives we are going to discuss. And the first type of adjective we are going to discuss is adjectives of quantity. Quantity means size. So based on size, how many types of adjectives we have? So kinds of adjectives. Following are the kinds of adjectives. We have adjectives of quantity. Adjective of quantity shows how much of something is described. How much? It is based on size. She has some time. How much time? Some time. So some is the quality here. Okay, that is how how much time is there. It is describing about the time. So it is some is a adjective of quantity. Sheila has little patience. How much patience? Little patience. He have less money today. How much money? Less money. So saying about the quantity, we have these adjectives of quantity. We have some examples. Some, little, less. And next type we are going to discuss adjective of number. Yes, Rishikesh, you have any doubt till here? Rishikesh? Rishikesh, why did you raise a hand? You're not audible. Okay, try to leave the class and join again. And next type we are going to discuss, that is adjectives of number, numeral. It shows how many persons or things are described. It also shows the order of any person or thing. For example, there are 3 halls in the palace. How many halls? 3 halls. So 3, all numbers, the number of quantity, the number of numbers is also adjective. All students will pass this year. So what is the adjective of number used in this sentence? All. She got 3 awards. How many awards? 3 awards. So 3 is also an adjective. And next type of adjective is about quality. Quality means how is it? Is it fat? Is it thin? Is it tall? Is it short? Is it white? Is it black? So how it is? It shows the quality of any person or thing. That means it describes the attribute of any person or thing. Attributes means either it may be height, weight, color, gender, etc. So Sapna is an honest girl. So here honest is describing the quality of that girl. So honest word is adjective here. Which type of adjective? Adjective of quality. You are a foolish man. So which type of man? Foolish man. So adjective. Adjective of quality. Divya is a tall girl. So tall is saying about how high the girl is, that is tall. This is about adjective of quality. And next we have an important topic called degrees of comparison in adjectives. You must remember degrees of adjectives for all the adjectives. Degrees of comparison. A comparison can be made using the 3 forms of adjective. They are positive degree, comparative degree, and superlative degree. Shimla is a beautiful place. You are saying about only one thing. Then you use the word beautiful. So beautiful is in which degree? Positive degree. Positive degree says only about one thing. But you are comparing this with another thing. That means comparison is happening between two things. Shimla is more beautiful than Dehradun. That means we are comparing Shimla and Dehradun using more beautiful. So this more beautiful is comparative degree. We are comparing between two things. And Shimla is the most beautiful place in the Himachal Pradesh. That means out of all of them, Shimla is the most beautiful. Then more than two things comparison is happening, and clearly one is the winner. Then that adjective is used in the sense of degree. Which degree? Superlative degree. So positive degree is beautiful, comparative degree is more beautiful, superlative degree is most beautiful. From the above sentences, beautiful has been used in three different forms. So these are called degrees of comparison. Let's take one by one now. First, positive degree. Okay, let's take positive degree. It is used when no comparison is made or both the things have equal number of quality. That means whenever comparison is not happening, only about one thing we are saying how it is, then it comes under positive degree. Sita is a tall girl. Is there any comparison happening between Sita and any other girl? No. So just say that Sita is a tall girl. So tall is positive degree. And while comparison also we can use positive degree, but when they are of same quality, like Sita is not as tall as Sheila. So whenever as comes, then we have to use positive degree only, not comparative or superlative. So here you can see as whenever as there, we can use still comparison, but positive degree must be used. So remember this, whenever as comes for comparison, the degree must be used for that is positive degree only. Don't say that Sita is not as taller as Sheila. Use only positive degree, tall only. Remember that. The girl is a fast runner. So we're not comparing between anything, that only one girl we are saying positive degree, that is fast. So suppose we are comparing with Divya, the girl is as fast as Divya. So here also as comes. That means whenever as comes, the degree must be used is positive degree. So fast, faster, fastest. Use positive degree fast only whenever as comes. Remember that. And next degree, that is comparative degree. We'll take some examples. Comparative degree. It is used when two things or two sets of things are being compared. Sita is taller than Sheila. So when comparison is happening between two things, then two things are persons, anything, then we have to use comparative degree. Tall is the positive degree, taller is the comparative degree, tallest is the superlative degree. So because comparison is happening between two things, we have to use taller. Sita is taller than Sheila. The girl is faster than Divya. So here faster is the comparative degree. Next degree is superlative degree. Superlative degree of adjective. Superlative, what is that? So more than two numbers, the comparison is happening, and out of all of them, that is either most or least, then superlatives will be used. Either it is best or it is worst. Then both cases we have to use superlative. That means out of all of them, about one thing we are describing. More than two numbers must be there. If two numbers are there, comparative. More than two numbers are there, superlative. It is used when more than two things are being compared. Sita is the tallest girl in the class. So in the class, more than two members are there. So we use tallest, tall, taller, tallest. So tallest is the superlative degree. The girl is the fastest runner in the team. So in the team, more than two members may be there. So they are using the superlative degree fastest. So this is the meaning of positive, comparative, and superlative degrees. And now we'll take some rules for forming comparative superlative degrees from the positive degree using some rules. Harshvardhan, what do you want to ask?
Sir,
Yes.
sir, in a comparative and superlative degree, I have a doubt, sir. When we have to use that, suppose any sentence came means we want to compare
See,
two things.
See, Harshvardhan, the thing is very simple when to use comparative and when to use superlative. If the comparison is happening between only two things, go for comparative degree. Okay? And if it is happening between more than two things,
Sir,
suppose you want to say Sita is the tallest girl in the class. In the class, how many members are there? Two or more than two. So more than two members are there. So we can use tallest, that is superlative degree. Yes.
sir, suppose Sita is taller than we are using only one name means we want to use comparative.
The comparison is happening between Sita and Sheila. There are two members. That's why we are using comparative degree. Okay?
Sir, on comparative for only two members.
Yeah, only for two members. More than two members, superlative.
Okay.
So by adding ER and EST, most of the times we get comparative and superlative degrees, but always it may not be possible. But most of the times we can say by adding ER and EST, we can create comparative and superlative degrees. See, by adding ER and EST, positive, comparative, superlative. So bold, bolder, boldest. Clever, cleverer, cleverest. Cold, colder, coldest. Deep, deeper, deepest. You can see for the positive degree, ER and EST are added and we are getting comparative and superlative degrees. Every time it's not possible, but most of the time this will happen. Deep, deeper, deepest. Tall, taller, tallest. Smart, smarter, smartest. Strong, stronger, strongest. Weak, weaker, weakest. Next, second type of creating comparative and superlative degrees by adding only R and EST. Here ER and EST we won't add because the word is already ending in E. So we will not add one more E. Then we are going to get only R and EST added at the end. So you can see some examples for that. So second type of creation of comparative and superlative degree, that is brave. The word brave is an adjective. It's already ending with E. So we don't add extra ER. We add only R. That is brave, braver, bravest. Fine, finer, finest. Large, larger, largest. Simple, simpler, simplest. Nice, nicer, nicest. White, whiter, whitest. Wise, wiser, wisest. Daksh, what's your doubt? Daksh? Daksh, there is a lot of background noise.
Okay, sir.
Daksh, what is your doubt? Tell me.
Sir, nothing, sir.
And next, third type of creating the comparative and superlative degrees are by doubling the last letter and adding ER and EST to the adjectives whose second last letter is a vowel. So the rule for this is the last letter must be a consonant and before that we want a vowel. You look at the word big. Big is ending with which type of letter? Consonant. And before that I is vowel. So such type of adjectives are there. So when we are writing comparative and superlative degrees, the consonant at the end is going to double itself. That is G is going to repeat it two times. GG. So you can see big, bigger. G repeated twice. And biggest. Fat, fatter, fattest. You can see T is the consonant. Before that vowel is there A. So the consonant is going to repeat two times. Fat, fatter, fattest. Hot, hotter, hottest. Slim, slimmer, slimmest. Thin, thinner, thinnest. Red, redder, reddest. And fourth way of creating the comparative and superlative degrees, the adjectives ending with Y. Whenever the adjectives are ending with Y, we have to replace that Y with I and add ER and EST. So here what is happening, the change? Before adding ER and EST, Y is replaced with I. So if the adjective is ending with Y, something like busy, while writing comparative degree, don't write Y and just add ER. Y first will make it as I, then add ER and EST. So busy will become busier and busiest. Happy, Y will be replaced by I and we add ER. Happier, happiest. Heavy, heavier, heaviest. Healthy, healthier, healthiest. Dirty, dirtier, dirtiest. Easy, easier, easiest. Merry, merrier, merriest. Wealthy, wealthier, wealthiest. And next, fifth type of creating comparative and superlative degrees. Some adjectives change into comparative and superlative in irregular way. So what are those irregular ways? Some examples you must remember. Most of the people try to add er and est for all the words, but it won't work every time. Bad, you cannot write bad or baddest. Bad, worse, worst. Good, you cannot write good or goodest, you something like that. So good, better, best. Late, later, latest. Either you can use latter or last also. Much, more, must. Sorry, most. Many, more, most. Little, less, least. Here is there is no pattern of adding er and est, so they are irregular in a way. Okay, so that's why you must remember such exceptions. And next, we don't add er and est to quality words. Quality words means like describing the quality like intelligent, beautiful, etc. We don't add er and est to quality words, but use more and most before them. Intelligent, you have to say more intelligent, most intelligent. You cannot add er and est here. Beautiful, more beautiful, most beautiful. Courageous, more courageous, most courageous. Dangerous, more dangerous, most dangerous. Popular, more popular, most popular. Next, I'm going to give some questions, everybody one by one. I'll give you a choice to answer these questions. So first, let us revise what happened today's class. Then we'll start with the exercise questions. So first we started with the definition of adjective, and then types of adjectives. We discuss adjectives of quantity. Quantity means number. Adjectives of number, like how much size is there, that is quantity. How much number is there, that is number. Quality, adjectives of quality. And degrees of comparison, just now we discussed. Positive degree, comparative degree, superlative degree. And then simply adding er and est first way, and adding r and st because it is already ending with e. Then the last letter is consonant, and before that we have vowel. Then the consonant will be repeated 2 times before adding er and est. Then if it is ending with y, we remove y and replace with I. Then add er and est. And some irregular ways of positive, comparative, and superlative degrees. And then finally, we use more and most before them. So after this, all of you try these questions. Fill in the blanks with correct adjective from the options. So these questions, whoever is first 3 questions, I'll give the choice for a student who want to say the answers for these 3. You may raise hand. Ashwardhan, can you answer the first 3 questions?
Okay, sir.
Yes, read the first question.
Due to hunger, the poor beggar had become very weak.
Okay, hunger means because he's not getting the food. Then
Sir.
if you are staying hunger for more time, then it will become definitely weak. Yes, which option is correct for first one, Harshvardhan?
Sir, option C. Sir, we have to copy.
No, copy later. Always you watch the recorded lecture again for revision and copy later. So in the class, you just look at the questions and answer. So C is correct. Very good. Second one.
Sir, the dash should not proud of their wealth. Sir,
Yes.
rich.
Yeah, who is proud of their wealth? Generally, the rich people. They're having wealth, the rich people. Rich. Very good. Third one.
The house is very costly, so I cannot buy.
We cannot buy it because it is very costly. Okay. So
Yes,
that is costly. Very good, Harshvardhan. You give all answers correct. You can
sir,
mute yourself now.
that 3 questions.
Shana, you want to answer the next 3 questions?
Sir,
Yes, fourth question, you can read it now.
he is weak, but his brother is strong.
Yes. Whenever but is there, is it's always used in the opposite sense. So weak opposite sense is the strong. Very good. Next, fifth one, read the question.
Sheila will not buy dash books. Sheila will not buy those books.
Here, books are there or book is there?
This book.
Book is singular. These is used for plural. Those is used for plural. Some also used for plural. So the only option left is this, right?
Sheila will not buy this book.
Okay. What about sixth one?
My brother had dash work.
Her brother had dash work. Yes. A lot of work, a number of work, the few work, few work.
Her brother had a lot of work.
Yes, a lot of work. That is option A. Very good, Shana. You gave all correct answers. You can mute yourself now. Next few questions I'm going to give. So those who wanted to give answer can raise a hand now. Yes, Samatrika, read seventh question. Samatrika, read seventh question. Samatrika, are you there?
Yes, sir.
Read seventh question.
There was dash milk in the glass.
Yes.
Sir, you zoomed.
Shall I zoom the questions?
No, sir. Zoom out.
Zoom out. Okay, I think you want it in the middle of the screen. Okay, no problem. Is it okay now?
Yes, sir.
Okay, read the question.
There was dash milk in the glass.
Yes. Many
Uh,
a milk, a little milk, each milk, a few milk.
a little.
Yeah, very good. Correct answer. And eighth question.
Dash the soldiers hide behind the rock.
Dash the soldiers hide behind the rock.
Few.
Few the soldiers. Will you say like that? Few the soldiers.
Each.
Will you say each the soldiers? Wrong answer.
All.
Yes, all is correct. All the soldiers hide behind the rock. Next, ninth one.
It was is dash day at the office.
It was his dash day at the office. Yes.
First day.
Yes, first day. That will match. Very good, Samatrika. You can mute yourself.
Okay, sir.
And Srivasto, can you answer the next questions? Srivasto, 10th question.
He could not prepare the dash 2 lessons.
He could not prepare dash 2 lessons.
Last 2 lessons.
Yes, very good, correct answer. 11th one.
The dash money he had was spent on his education. More money. Sir, more.
No, already he spent on his education, right? He's saying about the spent one. So the little money he had, that will be more general than more. So the little money he had was spent on his education. Next, 12th one.
Dash employees were dismissed from their job. Each.
Each, after each, you have to go for singular one, but employees is plural.
Some employees were dismissed from their job.
Yes, correct answer. Very good, Srivatsa. Remaining questions I'm going to give it as your homework, and I'll give the answers later next class. Now you can try the next few questions I'm going to give here. So this will be your homework. Try these questions. We'll discuss tomorrow from 13th one. You can pause the recorded lecture whenever you want to copy all these questions in your book and answer. Yeah, we'll discuss the answer for these questions tomorrow. But be ready with your answers in the book. Okay, these are the questions I gave, starting from 20. So this is from adjective topic that we discussed today. So all the students, thank you for joining. You may leave the class now.